So now that we're able to output to the screen, let's talk a little bit about the kinds of data types for the most part that we are going to stick to. Now, these are what are referred to as primitive data types, and for whatever reason, Chapter 2 does not give you a nice, easy table to look at. So what you'll notice is in the Chapter 2 page on Eagle, I have two links for you. One of them to Tutorials Point that has a listing of those primitive data types, and that's actually what we'll be using for the reference here. And another one is to the Microsoft Developers Network, that's MSDNA, is academic, that one's us, to their list of primitive data types and uses. And quite frankly, if you just want to flip over in the text to page 600, here's a nice little table. It's table 11-1 that kind of goes over what those primitive data types are, and that's the table I'll be pointing to here for this particular podcast. So let's start at the top. Why is it called a primitive data type? A primitive data type is built into C++. You don't have to worry about going through any extra lengths. You don't have to include any additional includes, for example, at the very top of your program. These are types of data that C++ by default is going to be able to handle, to save, to do math with, to do assignment with, to do whatever it is that you are going to need C++ to do. First and foremost, why don't we start with integer, int, that's the key word there. Integer is exactly what it sounds like. It is a whole number. So it is, the number 1, the number 2, the number 3. And in total, it is 4 bytes of data. So that means it's actually a relatively large data type. So if you're thinking about really minimizing the space that your C++ program is going to use, for us, this is not going to matter. I'll tell you honestly, simply use integer if you are using a whole number. But if you are making a large-scale database, absolutely, if you don't need the numbers negative, here I'm just going to read the number off to you rather than putting the commas in there. It is from negative 214783684 to positive 214,748,300, or whatever it is. It's a very, very large range of numbers. If you are building a database, if you are building something architecture-wise very, very scalable, where speed and where storage really make a difference, you can use a short int. That's short space int is the keyword. You can see that here again on page 600. That is considerably smaller. That is only 32,768 positive to 32,768 negative. So it's a much smaller, much more compacted. It only takes up 2 bytes worth of data to save a short int as opposed to a full integer number. Again, those are whole numbers. Next, let's look at the character type. This is 1 byte of data, and you're looking at any character essentially on your keyboard. The letter A, the letter B, the letter capital A, the letter capital B, the tilde, the bracket, whatever you need, those are characters. So if you just want a user to enter Y or N, a character is a good variable assignment to use for that. If we're working with data, if we're working with numbers, if we're working with things, think tax rate, we would be using double or floating point numbers. If we're looking back on the table 11-1 on 600 again, these would be float and double. Float is the smaller of the two of these. It's still actually relatively big for the data types we're looking at here. We're looking at 4 bytes of total storage, and you're looking at around 7 total digits of specificity here. So if we're looking at a tax rate, 5.68, that's perfectly okay. If we're looking at a relatively large-ish number, that's okay, until we get to a larger number. If you're working with data that is more than, let's say, for example, 6 digits long, we would be looking at a double as opposed to a float. So when you have extremely precise data that we're looking at. So for the most of us, this is not going to happen necessarily over the course of the class here. But if you're thinking about things like extremely precise measurements for location, extremely precise measurements for time and distance and things, absolutely you'll want to use a double or a long double for that. But for most of the applications we're going to build here for the class, a float is perfectly going to meet that need for you. The very final data type here that we're going to discuss, especially here for Chapter 2, that is going to be of use to you is going to be the string class. Now, string is not a primitive data type. There's actually an entire library worth of functions that you have to include. So that's that hash include string that you would put at the very head of your program. This has to be included there. Strings are, I hate to define it by using the word again, but it's a string. It is a host of numbers and letters or characters or whatever it is that you need in order to get something done. If you think about something like last name, your last name is certainly not an integer. It's not a double. It's also not a character for the most part. So absolutely we would have a string for that. As we'll see in some future chapters, strings bring with it, as part of that class library that you're importing, or including rather, their own set of rules and its own set of functions that we're able to use. So the string class is actually one of these colossally important pieces to just average program design. It's not very common that a user is going to be interacting with a large-scale program. Think Google, for example. The back-end portions of the Google search engine for that database are going to be built off of C++. It's very, very low overhead, very, very fast. And it's very rare that I put the number 4 into a search box in Google and expect to see something there. I rather put a string in there. What is the meaning of the number 4? And Google would respond to me, "Are you having an existential crisis?" ? Because if I'm looking up the number 4, probably I am. So string is the very last class here. Data type, rather, that is a class here in the book, and that is, you can see that on page 52 if you're curious. If you go ahead and flip over to page 57, we have the Boolean data type. Booleans are either yes or no, true or false, on or off, exists or does not. You can think of it as like alive or dead. You can't be both of them. We don't have vampires, we don't have zombies, so there's nothing that's in between. You're either alive or you are dead. In C++, the way that this would be typed to you is either true or false. You can see in that little programming block there on page 57, you can actually request C++ tell you true or false, but otherwise true is 1, false is 0, and that's the way the display you can see at the very bottom of program 2.17. That's in the program output there. False is 0, true is 1.